Welcome. We're going to take a look at measures of central tendency and introduce a new word called an outlier. So let's take a look at an example. So in a 5K run for charity, 10 participants were randomly selected, and the ages of those participants in years are provided. So I've gone ahead and sorted the data for us to make it a bit easier. So let's start here. We have an 11-year-old, an 11-year-old, 13-year-old, etc. So pretty young group of people running in this race. 16 years old, there's an 18-year-old. And then finally, I have an 89-year-old. So I hope when I'm 89, I'll be able to run a 5K. But the point here is that that 89-year-old is certainly very different in age from all of the other values in that data set. So when we have a number that is so different from the rest of the values, we call it an outlier. And I'm going to show you a graph of this data as well to really emphasize that. So on the graph, I've done a dot plot or a line plot. So I would have two dots at 11 and then three 13-year-olds, the 15, the two 16s and the 18. And then on a number line, that 89-year-old is very far away from everybody else in this sample. So again, that's what we call an outlier in a data set. All right, so we'd like to see what the three measures of central tendency are that attempt to describe a typical value in that data set. And let's just jump in first with the mean. So if we chose to use the mean to attempt to describe the typical age of these participants in the sample, so they were randomly selected. So that's the assumption here that that means it was a sample of these participants. So X bar for sample mean, and the formula is sigma. We add the data values and we divide by n, the sample size. So on my calculator, I've already added up all the data values, and that will be 215. And then I'm going to divide that by the sample size. We had 10 data values, 10 participants, and that's going to come out to be 21.5. So I can say the mean, or we often say the average. So the average age of participants sampled is 21.5 years old. Now, if somebody told you the average age of a group of people was 21.5, it might not seem like a very good picture of this data, because if we look at the data, all the participants are actually under 21. So 11 to 18, they're all under 21, except for the outlier. So 21.5 doesn't seem like a very good way to express the ages of these people as a typical value. So let's take a look at the median. So the median as a measure of central tendency is the middle value when the data has been sorted or put in order. So I have 10 numbers, so the middle, 1, 2, 3, 4, 5. So right between the 13 and the 15 would be our median value. So when we have 10, an even number of numbers, the median will be the average of the two middle numbers. So I'm going to take that 13 and 15 and add those, divide by 2. And then order of operations, we do our numerator first. That will be 28, divide by 2. So the median is 14 years old. And 14 years old does seem a better way to describe the typical age of these participants. So forgetting about the 89 here, the 14 is a good idea of the measure of central tendency. I think is more instructive of what is happening in the participants' ages. And then we'll just add the mode here for practice. So mode is the data value that occurs with the highest frequency. In other words, it occurs the most in the data set. And in this case, the 13 occurred 3 times more than any other number. So that is our mode. All right, units one more time. So 13 years old. All right, so 13 years old, 14 years old seem to be pretty good descriptors of the majority of the data set. So that outlier 89, that value isn't included in the mean or mode calculations. That value is only occurring in the mean calculation because we added it among the 10 participants. So what's happening here is 21.5 is a little misleading because that 89 is going to bring up the mean to a value that's greater than all the participants except for that outlier. So what we do is we ask ourselves, what would happen if we just removed the outlier from our data set and decided not to continue using it in our data analysis? And we're going to see what happens to our measures of central tendency. All right, so I rewrote the data. So I took out the outlier. So now I don't have 10 values. I only have n would be 9 values. So we have an odd number of values. And now when I draw the dot plot, it'll be easier to see. So there's our participants. And now let's take a look at the mean. So with the outlier removed, if we add the data values and divide by the number of values. So I already added all the data values and got 215. So I'm just going to type 215 on my calculator here, 215. So I'm going to take away the 89-year-old. So that means when I add up those values, I'm going to get 126. And now I'm dividing by 9. So 126 divided by 9 is 14. All right, I'm not going to write the units again here, 14 years old. All right, so that again seems pretty good as a measurement of sort of what's typical in that data set. So the mean now seems to be a pretty accurate representation of typical. The median, so now we have an odd number of data values. So the median will be a value in the middle of the list. And again, it's sorted already. So if I go 1, 2, 3, 4, that 13 will be the value in the middle. 4 numbers to the left of it, 4 numbers to the right of it. So the median doesn't need a calculation. It's just that number in the middle. And then the mode, the 13 is again occurring more than any other value. All right, so then we just do a little comparison here. All right, so the value that I saw a big change in with or without the outlier. So if we took a look at the mean, so when we had the outlier in the data, that came out to be 21.5 years. So that 89 was having quite a big impact, sort of misleading us into thinking the average was higher than what I would call typical for most of the data. But when I took out that 89, that mean dropped from 21.5 down to just 14. So that outlier had a big impact, a big change on the mean with it present versus removed. However, the median didn't change quite so much. So it was 14 with the outlier, 13 without the outlier. So there was a change, but it wasn't really a significant difference. Both seemed to still be a pretty good representation of what would be typical for the data set. All right, and then the mode stayed the same. But let's just address mean and median. So because the median was relatively unaffected by the outlier, so 13 versus above 14, the median is generally not highly affected by outliers, so we call it a resistant statistic. It resists change when outliers are present because it's just that middle value in that sorted list. So the outlier, the 89-year-old over there, doesn't affect the middle significantly, but the mean had a pretty substantial difference when we had the outlier versus not. So up above it was 21.5, and then it dropped to 14 when we took out the outlier. So we call the mean sensitive. So sensitive to outliers means you're going to see a substantial impact on its value. So if we're working with data sets and we are aware of outliers, or we're studying a population and we know that outliers are highly likely, then rather using the mean as a choice for what's typical in the data set, it's often the better choice to discuss the median because it is not as impacted by the presence of potential outliers. All right, so there we have it. So good review of mean, median, mode, and then just how outliers can affect those measures of central tendency.